Welcome friends. In continuation with our lecture series in network analysis and synthesis, now today we are going to discuss about the nodal analysis. So, the content that we are going to cover in today's lectures are learning outcomes, definition and types of nodes, important steps in nodal analysis, and we will solve finally few practice questions. So, the learning outcome of today's lecture is to develop an understanding of how to use Kirchhoff's current law to write node equations and then to solve for unknown node pair voltages. So, let us start with the definition of nodes. Node is a point where two or more elements have a common connection. So, let us consider a network. So, you can see this is the point where more than two branches have a common connection. This is the point where more than two branches have a common connection. This is the point where more than two branches are having a common connection, and finally, this is the point. So, all these points can be called as node. So, node is nothing but a point where two or more elements have a common connection. Now, let us discuss about the types of node. So, first we will begin with the ground or datum or reference node. So, the voltage, a node whose voltage is assumed to be 0 is considered as reference node. So, I will repeat once again, the node whose voltage is assumed to be 0. In figure, this is the node whose voltage we are assuming to be 0 volt, hence this will be called as the datum node or reference node, and this will be used to find out the voltages of other node with respect to this only. That is why this is called the datum node or reference node. Next is the definition of independent node. So, a node whose voltage with reference to datum is not known is called independent node. So, in this network you can see this is the datum node whose voltage is 0 volt. With reference to this, the voltage of this node is not known, hence this will be called as independent node. The voltage of this node is also not known with respect to this reference. So, this will be another reference node, independent node. So, in this network, node number 1 and node number 2 are the independent nodes. Why they are the independent nodes? Because their voltage with respect to datum is not known. So, node 1 and 2. So, a node whose voltage with reference to datum is not known. So, in this network node 1 and node 2 are independent nodes, as their voltages with respect to datum is not known. Next is the definition of simple nodes. Simple nodes are the nodes whose voltage with respect to datum is known. So, now you can see this node number 3. Between node number 3 and 0 there is a direct voltage source connection. So, the voltage of this with reference to 0 or with reference to datum is VB volt. So, the voltage of this node is known, hence this will be called as simple node. So, datum node, independent node and simple nodes, these are the different type of nodes. Our focus will be there in nodal analysis. So, datum node is the node whose voltage is assumed to be 0. Independent nodes are the nodes whose voltage with reference to datum is not known. Simple nodes are the nodes whose voltage with reference to datum is known. So, these are the different type of nodes. In nodal analysis, actually what we are going to do? In nodal analysis, we are going to find out the independent node voltages with reference to datum node. So, this will be the approach in nodal analysis. We will try to find out the voltages of independent nodes with reference to datum node. The method is based on the application of Kirchhoff's current law. In mesh analysis, we were using Kirchhoff voltage law. Here in nodal analysis, we make use of Kirchhoff's current law. General form of the matrix or general form of the equation is admittance matrix into voltage matrix equal to current matrix. This will be the basic equation of nodal analysis. So, the method is based on Kirchhoff's current law, and the general form of the equation is admittance matrix into voltage matrix equal to current matrix. Now, we will discuss about what are the important steps we are going to consider in nodal analysis. So, first step is to identify the different type of nodes in the network. First, we will identify what is the reference node, what is independent node, what are the simple nodes. So, identification of nodes. After identifying the different type of node, the second step is to assign the node voltages to each independent node. This will be the second step. First step is the identification of the nodes. Second step is to assign node voltage to each independent node. Third step is to apply KCL at each independent node and write the KCL equations. After writing the KCL equation, these equation we will solve using Cramer's rule to get independent node voltages, and after getting the independent node voltages we can find out the currents. Now, here in nodal analysis what we do, suppose a resistor is there and the voltage at two ends of a resistor are V1 and V2. So, how will you obtain the current? Current is difference of voltage divided by resistance. Why V1 minus V2? Because we have assumed the direction of current from V1 to V2, it goes from higher voltage to lower voltage. So, current will be V1 minus V2 upon R, or since we know the reciprocal of resistance is conductance. So, this equation can also be written like this, conductance multiplied by V1 minus V2. So, this will be the basic approach to write for the current at different nodes. So, current is difference of voltage divided by resistance or difference of voltage multiplied by conductance. So, this is the approach we are going to apply in writing the node equations. Now, let us consider one network. Now, here in this network you can see how many nodes are there. This is the node with maximum branch termination. Generally, datum node is considered as the bottom node with maximum branch termination. So, here 1, 2, 3, 4, 1, 2, 3, 4 and 5 branches are terminating at the bottom node. So, this will be treated as reference node and its voltage is assumed to be 0 volt. Now, we will try to find out the voltage of different nodes with reference to this. So, we can see there is no direct source connection between datum node and this node. So, voltage of this node is not known. So, this will be treated as the first independent node. So, this is independent node number 1. This is independent node number 2. Why independent node number 2? Because there is no direct source connection between this datum and this node. So, this will be independent node number 2. So, in this network there is one datum node and two independent nodes. Now, after identification of the nodes, we will assume voltage at independent node 1 is V1 and the voltage at independent node 2 is V2. So, after assigning the voltages at independent nodes, now we will write the KCL equation. So, let us write KCL equation at node 1. So, now for writing KCL we know we will have to apply the proper sign convention, and sign convention that we follow is current entering into the node is positive, leaving the node is negative. We can also follow the opposite convention. Opposite convention is current leaving the node positive and entering the node negative. So, here we will write the equation because we can save one step. So, we will go with the opposite convention, so that equation can be written in specific format, but original convention will remain same ki current entering into the node is positive, leaving the node is negative, but for writing the equation we will follow the opposite convention. So, the voltage at this node is assumed to be V1 and the voltage of this independent node is V2. Let us write KCL at node 1. While writing KCL at node 1, we will assume that V1 is greater than all other nodes. So, that it will supply current in outward direction. So, how many branches are there? 1, 2, 3, 4. These 4 branches are connected with node number 1. So, we will have to sum 4 currents. So, what will be current in this branch? This is the resistance, voltage at this end of resistance is V1 and voltage at this end of resistance is VA. This voltage we are writing with reference to datum. So, minus to plus, the voltage of this is VA. So, now what will be current in first branch? Resistive branch RA, V1 minus VA, difference of voltage divided by resistance, V1 minus VA divided by resistance. This is the current. Current is leaving, so it will be considered as positive. Current in the RB, V1 minus 0 upon RB, V1 minus 0 upon RB. Now, current in this branch, V1 minus V2 upon RC, V1 minus V2 upon RC, and there is a current source directly connected here, and this current source is supplying current at this node. This current is entering into this node, and hence it is considered as negative. So, minus IA. So, this will be the KCl equation at node 1. Now, we know that reciprocal of resistance is conductance. So, 1 upon RA is GA. So, GA V1 minus VA, GC V1 minus V2, GB V1 minus IA equal to 0. Now, we will combine the coefficient of V1, V2 and other constant term will be transferred to right hand side. So, we will get the equation GA plus GB plus GC into V1 minus GC V2 equal to IA plus GA VA. This will be the equation 1. Next, write KCl at node 2. This is node 2. How many branches are there? 1, 2, 3. So, summation of 3 current must be 0. Again, when we will write KCl at node 2, we will consider V2 greater than all other voltages. So, it will supply current in outward direction. So, what will be current in this branch? Difference of voltage V2 minus V1, V2 minus V1 divided by RC. What will be current in this branch? So, to write current in this branch, voltage at this end is known V2, voltage at this point will be minus half VB, because this is 0 and we are moving from plus to minus. So, this is having the voltage minus VB. Now, what will be current here? V2 minus minus VB, so, V2 minus minus plus. So, it is V2 plus VB upon RG. Now, again there is a direct current source connection, current is leaving the node, hence it is positive. So, all 3 current, because V2 is greater than V1. So, it will supply current in this direction, V2 is greater than VB, it will supply current in this direction, current source is drawing the current. So, summation of all 3 current must be 0. Reciprocal of resistance conductance. So, this equation can be written as GC V2 minus V1 plus GD V2 minus VB plus IB equal to 0, or you can rewrite the equation in this format. So, by writing KCl at node 1 and node 2, we have obtained equation 1 and 2. Rewriting the equation 1 and 2 in systematic form: coefficient of V1, coefficient of V2 constant term, coefficient of V1, coefficient of V2 constant term. Now, this can be arranged in matrix form. So, conductance matrix multiplied by voltage matrix equal to current matrix. So, here since it is a resistive network, the general form of the equation we will get is conductance multiplied by voltage equal to current matrix. This will be the general form of node equation in matrix form. Now, since there are 2 independent nodes, you can see the order of conductance matrix is 2 cross 2. There will be 2 unknowns V1 and V2. So, the order of voltage matrix is 2 cross 1, and since number of column in first equal to number of row in second, the resulting matrix is a current matrix of the order 2 cross 1. So, in generalized concept, you can say that if there are n number of independent nodes, the conductance matrix will be of the order n cross n, voltage matrix will be of the order n cross 1, and the resulting current matrix will be of the order n cross 1. After getting the matrix equation, we can solve this equation by Cramer's rule to obtain independent node voltage V 1 and V 2. So, V 1 is del 1 upon del, V 2 is del 2 upon del. So, here in this equation del, del 1 and del 2, these are the different determinants. So, now we will see what is del. Del is nothing but, because the general form of the equation is conductance matrix into voltage matrix equal to current matrix. So, del is nothing but determinant corresponding to conductance matrix. So, here conductance matrix we got is G A plus G B plus G C minus G C minus G C, G C plus G D. So, determinant of this matrix is del. To obtain del 1, we will replace this first column of conductance matrix by the right hand side column. So, this replacement will give this determinant. So, determinant of this will give you del 1. To get del 2, we will replace this second column by right hand side column. So, this replacement is done and the determinant corresponding to this is del 2. So, after getting del, del 1, del 2, we will get V 1 equal to del 1 upon del, V 2 equal to del 2 upon del, and after getting V 1, V 2, we can find out current in each and every branch. So, this is the nodal analysis. Now, we will generalize the equation. So, we have already seen that the general form of the equation is G into V equal to I. So, this is the general form of the equation. Since there are two independent nodes, this is of the order 2 cross 2, voltage matrix is of the order 2 cross 1 and current matrix is of the order 2 cross 1. So, since there are two independent nodes in the network, matrix G is of the order 2 cross 2, voltage matrix is of the order 2 cross 1 and the current matrix is of the order 2 cross 1. The general, since it will have 4 elements, the general elements are G 1 1, G 1 2, first row first column, first row second column, G 2 1, G 2 2, second row first column, second row. So, these are the 4 elements corresponding to conductance matrix. Now, let us see how we can write directly these elements, because this is the matrix we got by writing KCL at node 1 and node 2. So, these are the elements corresponding to diagonal. G 1 1 is G A plus G B plus G C, G 2 2 is G C plus G D. Now, try to find out these elements directly by observation. So, in this general matrix, first we will focus on the diagonal elements G 1 1 and G 2 2. So, in this matrix G K K, general form of the element, it is sum of all the conductances associated with node K. So, if we talk about G 1 1, it is sum of all the conductances associated with node 1. Now, let us see how many conductances are connected with node 1. Node 1 is having 4 branches, but in this branch there is a current source, no conductance. So, conductance corresponding to R A is G A, conductance corresponding to R B is G B, conductance corresponding to R C is G C. So, summation of all the conductances associated with node 1 is G 1 1. What is G 2 2? Sum of all the conductances associated with node 2. Let us see how many conductances are connected in node 2. 1 2, corresponding to this G C, corresponding to this is G D. So, summation of both the conductances G C plus G D will give you G 2 2. Now, G K J G J K is the sum of all the conductances common between node J and node K. Sign is always negative. So, if we talk about G 1 2, it is the conductance common between 1 and 2. So, 1 and 2 common is G C. So, G C is the conductance common between 1. Similarly, between 2 and 1 again G C is common and the sign is always negative. Why negative? Because when we write KCL at 1, we consider V1 greater than V2, and when we write KCL at node 2, we consider V2 greater than V1. So, two currents will have opposite direction, and if the currents are having opposite direction, sign will always come out negative. So, this is how we can generally find out all the elements of the conductance matrix directly by observation. V is the voltage matrix of unknown node voltages. So, there are two unknown voltages V1 and V2. So, it is a column matrix V1 V2 of the order 2 cross 1. If there are n number of independent nodes, it will be a matrix of the order n cross 1. Now, finally, the current matrix. So, current matrix will have two elements I1 and I2. So, I is the current matrix, and IK, element IK is sum of all the currents entering into the node K due to various sources connected with it. So, let us consider I1. So, I1 is sum of all currents entering into node 1. So, let us see node 1, how many sources are directly connected. To node 1, this is one current source and this is voltage source. So, current source is supplying a current of 1 ampere. So, contribution made by this current source is 1 ampere, and current contribution made by this source, because this source will supply current like this. So, V A upon R A. So, 1 ampere current is supplied by this, or I ampere current supplied by this, and V A upon R A current supplied by this voltage source. So, now there are two currents entering into this node because of the two independent energy sources. So, I A, so suppose this is I A. So, I A plus G A into V A, G A is the conductance corresponding to R A. So, G A V A. So, this is the net current entering into node 1 due to two energy sources which are connected with node 1. Similarly, I2. I2 is the net current entering into the node 2 due to all sources connected with it. So, IB is the current. So, this current is leaving. So, it is negative minus IB, and the voltage source is connected like this. This will draw the current because current goes from minus to plus. So, VB upon RD. So, this current is again leaving. So, minus VB upon RD. So, this is the net current. So, minus to plus, this is leaving. So, this sign will again come out negative. So, minus IB minus GD into VB, it is the net current going out of this node. So, it is negative. So, both the signs will come out negative. So, this is how we can directly write the equation by observation. So, what are the important steps in the nodal analysis? First, you need to identify the nodes. So, we will first identify datum node, independent nodes and simple nodes. What are the independent nodes? These are the nodes whose voltage with reference to datum is not known. Simple nodes, these are the nodes whose voltage with reference to datum is known, and reference node is that node whose voltage is assumed to be 0 volt. After assuming the voltage, we will after assuming the voltages of independent node, we will write Kcl equation at each and every independent node. After getting the equation, we will form the matrix. After getting the matrix, solve by Cramer's rule for getting the independent node voltages, and after getting this, we can find out current in each and every branch. So, let us solve one question based on the nodal analysis. So, now in this question, let us consider this as the datum node. Why datum node? Generally, bottom node with maximum branch termination is considered as datum node. So, 1, 2, 3, 4, 5 branches are terminated. Let us consider this as 0. So, this will be treated as the reference node. So, selection of reference node is very important. We should select such a node as reference node whose where maximum branches are terminating. So, this is the node where 1, 2, 3, 4, 5 branches are terminating. So, its voltage will be treated as 0. Now, this will be another node, but its voltage is 2 volt, because there is a direct source connection between datum and this. So, its voltage is known to us. So, this will not be a independent node. because its voltage is known, that is 2 volt with reference to datum. So, this will be treated as a simple node. Now, there is no direct source connection between this and datum. So, this will be the first independent node. There is no direct voltage source connection between this and this. So, this will be a second independent node, and this is simple node. So, now in this network there is a simple node, datum node, and 2 independent nodes, node number 1 and node number 2. So, this is the first step, identification of the nodes. The second step is to assign independent node voltages. So, let us assign independent node voltage for node 1 as V1 and the voltage of this independent node 2 as V2. So, this is the second step, ki assignment of independent node voltages. After assigning the independent node voltages, third step is to write KCL at each independent node. So, let us write KCL at node 1. So, while writing the KCL at node 1, you need to keep in mind one important thing. We will assume node 1 voltage as greater than all other voltages, and sign convention that we will follow is outgoing current positive, incoming current negative. So, current in this branch. So, voltage of this point with reference to datum is 2 volt, moving in this direction minus 2 plus. So, voltage of this point is 2. So, what will be current in this branch? V1 minus 2 upon resistance, difference of voltage divided by resistance, and V1 is greater than this. So, it will give outward current, that is considered as positive. So, current in this branch is V1 minus 2 upon 1 by 2. This will be the current in first branch. Now, consider current in this second branch, 2 ohm resistance. So, here voltage V1, here voltage is 2 volt. So, difference of voltage is V1 minus 2 divided by 2. Again V1 minus 2, it is leaving the node, it will be positive. So, plus V1 minus 2 divided by 2. What will be current in this branch? V1 minus V2 upon 1. So, this is V1 minus V2 upon 1. So, let us cross check how many branches are connected with node 1, 1, 2 and 3. So, summation of all 3 current must be 0. So, 1, 2, 3, this must be equal to 0. So, this is the KCL equation at node 1. Now, similarly, you can write KCL equation at node 2. So, let us see what will be the KCL equation, or you can simplify before writing KCL at node 2. This will be 2 V1 minus 2 plus V1 by 2 minus 1 plus V1 minus V2 equal to 0. Now, you can combine the coefficients, 2 plus 1 3, 7 by 2 V1 minus V2 equal to 5, 4 plus 1 5. This is equation number 1. So, the equation 1 is 7 by 2 V1 minus V2 equal to 5. This is 1. Now, similarly, we can write KCL at 2. So, how many branches are there at 2? 1, 2, 3 and 4. So, let us write current in this 1 ohm V2 minus V1 upon 1. Current in this branch V2 minus 2 upon 1. Current in this branch V2 minus 0 upon 1 by 2. And this current source is supplying a current of 1 ampere in this node. So, since we are following the opposite convention, minus 1 equal to 0. So, again you can simplify the equation in this format. So, the equation that you will get is minus V1 plus 4 V2 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 2 V2 4 V2 equal to 3. So, this is the Kcl equation at node 2. Then you can form the matrix. So, what will be the matrix equation? 7 by 2 minus 1 minus 1 4 V1 V2 equal to 5 3, and after getting this, V1 will be del 1 upon del, V2 is del 2 upon del. So, this is how you can find out V1 and V2 by using nodal analysis. But in this question, we need to find out I1. And what is I1? I1 is the current in 1 ohm resistor. Direction of current I1 is given. It is going from this to this. So, V1 minus V2 upon 1. So, what will be the current I1? Current I1 will be V1 minus V2 upon 1. So, after getting V1 and V2, we will get the current I1. So, this is how to solve the question by using nodal analysis. Now, let us consider one more question for practice. In this network, you need to find out I2 using nodal analysis. So, again first step is to identify the different type of nodes. So, let us consider bottom node with maximum branch termination as reference node. So, this is the selection of the node. So, bottom node with maximum branch termination is considered as datum node and its voltage is assumed to be 0. Now, there is no direct source connection between this and this. So, this is the first independent node. Let the voltage of this node is V1. This is another independent node because there is no direct voltage source connection. So, this will be independent node number 2. Let us assume its voltage as V2. Now, no direct source connection between datum and this. This is third independent node. Voltage of this is V3. Right. Now, KCL at 1. So, there are 3 independent nodes. Their voltages are V1, V2 and V3. This is datum node. So, KCL at 1. How many branches? 1, 2, 3, 4. V1 voltage of this point is 2. So, V1 minus 2 upon 1. Current in this branch V1 minus V2 upon 1. Current in this branch V1 minus V3 upon 1, and this current source is supplying a current of 1 ampere. Since it is entering into the node, minus 1 equal to 0. This is the Kcl equation at 1. Similarly, you can write Kcl at 2. Now, to write Kcl at node 2, you won't have any problem in writing current in this branch. It is V2 minus V1 upon 1. Because now we will consider V2 greater than all other nodes. No problem in writing current in this branch V2 minus 0 upon 1. Now, what will be current in this branch? We are writing KCL at node 2. So, these are the two ends of the resistor. Voltage of this end is known V2. What will be voltage at this known? This end, it is derived from this point. So, V3, and we are moving minus to plus. So, plus. So, V3 plus 2 volt voltage source is there. So, voltage of this point is V3 plus 2. So, now you can write current in this branch while writing KCL at node 2. V2, that is difference of voltage V2 minus V3 plus 2, because the voltage of this point is V3 plus 2. V3 is known here, minus 2 plus 2. So, V3 plus 2. So, V2 minus V3 plus 2 divided by 2. 1, 2, 3, 3 branches, summation of 3 current must be 0. So, this is the KCL equation at node number 2. Now, similarly, you can write KCL at node number 3. Again you can see 3 branches are there. Current in this branch, no problem, V 3 minus 0 upon 1. In this branch V 3 minus V 1 upon 1. Now, again to find out current in this branch, we will move like this. So, these are the two ends of the resistor in this branch. So, voltage of this is V 3 plus 2. So, V 3 plus 2 minus V 2, voltage of this point is V 2 divided by 2, this will be current in this branch. So, plus V 3 plus 2 minus V 2 divided by 2 equal to 0. 3 branches 1, 2, 3, summation of 3 current must be 0. So, after writing the KCL at node 1 and 2, node 1, 2 and 3, we will arrange these equations in matrix form and then use Cramer's rule for getting the independent node voltages V 1, V 2 and V 3. After getting V 1, V 2 and V 3, since in this question current I 2 is required and direction of current I 2 is given. So, current I 2 is current in this branch going from this to this. So, this will be at higher potential V 3 plus 2 minus V 2 divided by 2. So, this is how we will find out current I 2 in this branch using nodal analysis. So, this is all about the nodal analysis. I will revise the important points. First, we need to identify the nodes. After identification of the nodes, next we will assign independent node voltages. We will write KCL at different nodes, and after writing KCL equation, arrange these equations in matrix form and solve it by Cramer's rule to find out independent node voltages. Thank you.